you. Is this mic on? Great. So yes, I have the enviable spot of being between you and lunch. So thank you for attending my talk, and I will try to make it worth your while. So I'm a product manager at Pulumi, and we're building tools that make it easier to build modern cloud applications. Now, one thing that's really interesting is that there's kind of a divide in the community between serverless and containers. And you don't often hear about these things talked about at the same time. In fact, I think the talk before me was one notable exception to this. And that's not really the kind of talk that you see at serverless tracks at conferences. It's usually all about serverless. And serverless is fantastic. I first became excited about it a couple of years ago when I was at Microsoft and I worked on the Azure Functions team from when it was in early preview to a year after general availability. And what I saw was that serverless really made the cloud more accessible for people. Once there's a lot less to manage, and once you're thinking more about your code and not the underlying infrastructure, you end up with a lot of productivity benefits. Now, at the same time, there's a lot of hype about containers, and people say you containerize everything and your life will be better. So I'd like a show of hands. How many of you are running containers in production? So about half the room, I would say. And how many of you are running serverless in production? Actually looks like the same number of people. Awesome, this is perfect. So what I want to talk about is how to think about serverless and containers. So one option, as mentioned in the previous talk, is to consolidate all of this into one platform. So you can run everything on Kubernetes, and that has advantages. Another option is to use your vendor services and use all of the heavy lifting that they've done by creating a managed container service, by creating managed serverless options, things that have a lot of tooling and community behind them. Now, the question is, how do you choose for a given part of your application or an application itself? Which of these two options do you pick? And a lot of people talk about this because I think that when people learn a particular tool, they kind of want to use that tool to solve all the problems, especially when you've built up a lot of expertise in the tool and you get really excited about it. And so you learn about containers and you're like, containerize everything, it's gonna be awesome. And then you learn about serverless and you're like, event-driven serverless, it's awesome, everything will be great. And of course, the reality is somewhere in between. And so what I want to do here is talk about where these two compute models really shine and how to think about combining them into a full application. And one thing that helps here, and this is kind of the theme of the talks today, is think about tooling and how tooling helps you bridge the gap between these two very different approaches for building applications. So I saw this cartoon recently, which I absolutely love, which is kind of talking about this gap in the community between serverless and containers, where it's almost like there are these two warring tribes who are fighting each other. And you can see at this conference, for instance, there's a serverless track and there's a containers track. There's not a serverless and containers track. And I think this goes back to what I mentioned earlier. When you have a solution, you learn that tool really well, and you learn all of the things that it can do, it's very easy to think about that as the best solution to all problems. And I see a lot of folks, especially in the container space, talking about how containerizing everything and making everything a microservice just solves all problems. And people who are new to serverless will talk about it like it's some magic pixie dust that you just sprinkle on your application, and suddenly your application is better and more performant, it scales, and everything is wonderful. And of course, as Chase outlined for us earlier, that's not true either. So what I want to do is talk about combining these tools together and having a conversation about what architectures look like when they use a combination of these things. Because I think instead of having a divide, we need unicorns and rainbows and harmony rather than two warring tribes. Because there's no reason you should have to pick one or the other. There are a lot of options in the cloud, which is why it is so powerful. So let me talk a little bit about the trends that got us to this space. Why are containers and serverless so exciting? Well, before we had containers and serverless, we had VMs. And VMs are great because you don't have to buy and maintain physical hardware on premise. But the one thing that's really interesting is that when people are using virtual machines, your application architecture doesn't really change. In fact, applications were largely the same as when they were on-premise. They were large monoliths, and you still had to think about all the same things that you had to deal with on-premise. It's just that the physical hardware is no longer in your data center. So you need to think about patching your operating system. You need to think about your dependencies. Also, how are you going to get your application onto the VM? That's one of the things that makes it so hard to use the lower level of infrastructure. And of course, you need to think about things like scaling your app, and how do you scale it? So even though the cloud brought all these advantages, virtual machines didn't really move the needle on application development. And this is why there's so much excitement and energy around containers. You have a declarative format for specifying your application. You produce a Docker image, and then you use a container orchestrator to actually scale out your app onto your physical infrastructure, which means this is way more productive than when you're using raw VMs. You're essentially operating at a higher level of abstraction, and there's less to worry about. Now, I think the one thing that kind of turns serverless folks off about containers is that there is still a lot of machinery involved with doing containers. And this machinery most of it is necessary because you need a lot of control over your compute. And, as Stan Lee said, with great power comes great responsibility. So there's a lot to do. So you have a nice declarative format for your Docker file. You're specifying your OS, your platform dependencies, and packaging up your code. You need to build a Docker image. You need to put the Docker image into a container registry, and then you have to configure your container orchestrator. So for instance, you might be using Amazon's orchestrator with their Elastic Container Service, and you create something called a task, and you point that to your Docker file, and then you can create a service which is composed of tasks. So there's a lot to think about when it comes to your application. And this makes sense if you need this level of control. But that's the thing that you should ask yourself. Is this part of my problem, something where I need this level of control over my compute? So where containers really shine is, of course, they're a huge benefit over VMs. They're really up-leveling the idea of the compute that you have. And you get full control over your application environment. You want to run some old application that you have on-premise that's some big monolith. Containers are a great solution for that because you can control exactly what your dependencies are. And you can decide how your tasks are placed and how big your cluster is and how big your machines are that you're running on and all these things. But you do have to configure your orchestrator. For instance, on ECS, you write a task definition and a service description, which turns into a lot more things at runtime. So these are things that you have to think about for your application. You also have to provision physical compute. You have to provision a cluster where your compute is going to run. And for some applications, this is necessary, but for others, it isn't. And that's why there's a lot to manage in containers relative to serverless. So you have to think about your Docker file dependencies. It's true that you can run any kind of compute you want, but in the case of AWS, Amazon is deciding what OS to use. If there's a security vulnerability in some version of Node.js, they'll automatically update it. And they are maintaining that environment for you. When you have your own Docker file, you are taking this responsibility, which, of course, gives you a lot of power, but a lot of extra work. Also, you have to do a lot of things that don't really feel core to the problem when it comes to containers, such as building your container image, provisioning a container registry instance, creating tasks and pointing everything to the right places. So there's a lot more involved here. But of course, like I said, you have more control. You can decide exactly how many servers you need and how your application is going to scale. And I think this is why serverless is so exciting to people who have done things the old way, because you get event-driven compute with near instant scale. And of course, as Chase pointed out, there are a lot of caveats here. But the fact remains that serverless does scale better than any other solution out there today. And as Aparna said, there's more to serverless than just event-driven compute, but that's where the state of the art is. That's where the tools are the most mature. Serverless is managed and ephemeral. You can't SSH into the compute that's running on your function. And this is great, which means there's a lot of that work taken away from you. And of course, with consumption-based pricing, it can be really cost-effective. And of course, at this point, I'm going to mention that despite the fact that I really love serverless, I really don't like the term serverless. Because for one thing, everyone always points out, there's actually servers involved. And yes, of course, there are servers involved, but you don't think about them. So hopefully in a couple of years' time, people will stop picking on the name and start talking more about the compute that you're getting out of serverless. Now, I want to contrast the experience of building a serverless app with that of building a container-based app. With a container app, you remember there was a Docker file. You had to build all your dependencies. You had to define an entry point. You had to create a container registry instance. With serverless, you just provide your code. You're triggering off some set of events, and you give your cloud provider the definition of when you want your code to be triggered, and it decides how to scale you out. So a lot of the heavy lifting of running and managing your application is taken away from you. And this is really a good thing, because these are generally not things that are core to your business problem. You want to push this extra work onto your cloud vendor, who is doing this and doing it at a scale and at a low cost. So a lot of folks ahead of me have talked about the benefits of serverless. I completely agree. You have less operational overhead, a faster time to market, and really, when you're not managing servers, you get to spend that time solving your business problem, which means you're going to provide a better experience for your business and your customers. My favorite example of the improved time to market with serverless is when I worked on Azure Functions. We had a customer that we were going to do a training for, and we'd planned it about a month out, and we sent them a proposed agenda of the topics we'd cover. And when we got there, they're like, you can throw away that agenda. In the last month, we have been playing around with functions, and we've built a proof of concept working against real data. And what we want help with is taking this to production. And a month after that, they had their application in production. It was a small piece of an overall app, but they had it working. And this is the story that you hear time and time again. And that's why I think folks are so excited about serverless. It's almost like they have pitchforks going against the container people, because you have so much more productivity when you aren't thinking about the underlying infrastructure. So serverless is really great for event-based workloads. Things like scheduled tasks. You want to clean your data in your database every 15 minutes, and you're not paying for idle. Another common scenario is background processing. The Seattle Times does this. A photographer uploads a photo at full resolution, and it's uploaded to an S3 bucket, which triggers a Lambda function and resizes the image for web, mobile, and tablet sizes. Now, serverless is not the solution to every problem. I do not think that all apps should be serverless, and I don't think you should even try to make your app fully serverless. There are caveats to consider. For one thing, today it is best suited for event-based workloads. So I think the best thing to do is look at your application and find places that look like event-based architectures and opportunistically make those serverless. And think about ways you can make your application overall involve less management of infrastructure. Because it's not like there's some holy grail where, less servers is the answer. The answer is just think about what things you really need to manage in your application and what things you're comfortable handing off to your cloud vendor. And as others have said, one of the downsides of serverless is that you can't customize the execution environment. You can't choose what hardware you're going to run on. You can change how much memory you're using, but the compute is all uniform. And it's generally not well suited for long-running tasks. So the way I like to think about serverless versus containers is bikes. So you can rent a Lime bike, you walk up to it, it's ready for you to use. If your friends need bikes, there are bikes available. But the bikes are identical, and you can't customize them. I mean, you could, but it would probably be a big waste of time. Now, on the other hand, suppose you're commuting to work and you have a big hill that you're riding up. And if you're in Seattle, chances are there's a very big hill on your way to work. At this point, you probably need more gears. You need more features on your bike. At this point, it makes sense to own a bike because you are using it so much and you're customizing it so much that now it's worth it. And so that's kind of like serverless and containers. If you don't care about what the compute looks like and you just want to scale out on demand quickly, serverless is a great fit. If you need to customize your compute, if you have a specific Docker image that you need to run, containers are a great solution. And the thing that makes this problem much easier is that now there are new execution models for containers that are bridging this gap between serverless and containers. Because if you think about it, containers are, the idea is that you have a Docker file with your application. There's nothing inherent that says that means your compute must be provisioned ahead of time. So with features, with services like Azure Container Instances and AWS Fargate, you don't manage a cluster. You instead give a Docker image to the service and you run a container on demand, and it runs it very quickly. The price per hour is a little higher than if you had reserved the compute capacity, but the management benefits are enormous because you don't have to manage the underlying cluster, and you don't have to worry about scheduling the containers and making sure there's enough compute available. The platform is handling more of this for you. Now, tools are a great option for bridging this gap between serverless and containers. And tools really help take these abstract concepts and give you something concrete that you can use to build and deploy your application. And I think one reason that there's still this big divide between serverless and containers is that because serverless is still new, most of the tools in this space are focused only on serverless scenarios. And so that leads to this divide where people are naturally reaching for serverless when they maybe should be using containers. And what we're seeing now is a new trend where tools are thinking about all the resources that your application might use and how you might combine both serverless and containers in one tool experience. So let's look back at our example of containers, where there's a lot of goo that you have to manage here that is not inherent to running a container. So I want to talk about an application that might combine containers and serverless, and how you could build this out using some of these new tools that let you combine these two concepts together. So earlier, I talked about the Seattle Times and how they have a Lambda that resizes images. Now, let's change this problem a little bit. Suppose that they're also uploading video footage, and they want to produce a key frame from that image, that video that was uploaded. This changes the problem slightly because a video is typically very large, and it could take more than 5 minutes to process. And 5 minutes is the execution timeout on AWS Lambda. Another consideration is the easiest tool for manipulating video is FFmpeg, which is a program that has particularly complex runtime requirements. There are particular libraries that it expects to be installed in the system for it to run. Now, technically, there are ways to get this running in platforms like Lambda, but take these two things combined, and you see that this scenario is a better fit for containers on Fargate. So let's look at how that architecture might look. When a new video is uploaded to an S3 bucket, we'll have a Lambda that's triggered and says, okay, it's ready, let's do some processing. This Lambda will trigger a task in Fargate that runs FFmpeg in a container. And that writes out a JPEG, which triggers another Lambda, which might write back to a database with this new thumbnail. So now we have the event-based nature of Lambda that we're taking advantage of. But we're also using FFmpeg and don't have to kind of jam it into Lambda to get it to work. So I'm going to talk about how you might define this app in Pulumi, which is a tool that is one of these tools I talked about, where you can define both a serverless application and one that uses containers in a really seamless way. But the same architecture you could implement using any tool you'd want. So first, let's start with the Docker file. So we have that task that's going to write out to S3. So the Docker file is really simple. We'll use a pre-built container image for FFmpeg. We'll install Python and the AWS CLI, and then it's just a bash script. It copies the video from S3 using an environment variable to decide which bucket to read from, runs FFmpeg, and then it writes out a JPEG to that same bucket. So that's the container. But the interesting thing is, how are we going to stitch all of this together in a full application? So I'm going to show you some code written in Pulumi. The first thing you're going to see is this looks just like JavaScript. It is just regular JavaScript. The thing that's unique, though, is that instead of running this normally using Node, you instead run this code using the Pulumi command line tool. And what it does is it executes your program. It sees what resources have been requested. It looks at your target cloud and sees what resources you have and only provisions what's changed. So the first time you run this code, the bucket won't exist and it will create one. The second time, it will leave it unchanged. So you have the benefits of immutable infrastructure and minimal changes to your configuration, along with a high-level programming language that's a lot more flexible than something like YAML or JSON. And one thing I'll also point out is notice that the name of this bucket is bucket. This code actually works. What Pulumi does is it appends a unique identifier to the end of your name. You can, of course, override this with whatever you want. But what this means is if you have a new environment you want to run this code in, you don't have to change your code at all. It'll just work. So when you run this program so far through Pulumi, it'll create a new bucket. And of course, that's not particularly interesting. So let's get on to the compute. This is how you provision a Fargate container in AWS using Pulumi. And there's this one line here I want to point to where you point to a folder that contains the Docker file. That's the Docker file from the previous slide. Now, if you've actually ever deployed containers to AWS, you know that it is not this easy. It is not just 3 lines of code. It is, in fact, 2 pages of code to set up a bunch of different things. You need to build the container image. You need to provision a repository for your container. You need to provision the task. And for some reason, even if you're using Fargate, you need to talk about a cluster. And as Chase pointed out, there's a lot of IAM roles involved. Now, because all of this is just code, we built a library for this common pattern of how we were creating containers. And once you have a library, that's all where all the heavy lifting is, and that code that we're maintaining. And your code is really, really simple. And so in just 3 lines of code, you are provisioning about a dozen resources. But if you want to customize it, you can. You can build your own library that does something slightly different. And I think that this helps make containers more palatable for people who are really used to serverless, because the experience is much closer to just bring your code and run it, as opposed to now here's all this annoying infrastructure that you have to understand in order to do anything. So that's how we've defined our Fargate task. But now we need to wire everything up. So we'll do that with our Lambda. So in Pulumi, you can write your Lambda in line with the rest of your infrastructure if you want. So here, this is a Lambda that's triggered whenever a new MP4 file is uploaded. You can either write the Lambda in line or it can be in a separate file in a different language. But because this Lambda is really small, it's really easy to just put it in line. So that defines the Lambda. Now we need to run that task. So what we do in the Lambda is just invoke it. Because this is all code, and because the implementation of the Lambda is JavaScript and the infrastructure is also JavaScript, we can refer to that variable we created above, ffmpeg task, and we just say task.run. So it's a very natural experience for composing together the various kinds of compute in your application. Now, we need to tell the container what bucket to write to, and we'll pass that in as an environment variable. And again, here, we're just referencing that bucket that we defined above. And it's not some separate file that has config that you need to look up. It's very natural. It's very similar to how you reference a variable in your regular programming language. So that defines most of our code, and we just have one more lambda that's triggered whenever a new thumbnail is available. So it's going to trigger off of a JPEG file, and in this case, this code is really simple. It's just writing out to the console. In a real app, you're probably going to write to a database saying that the thumbnail and the video are available. So that's how you can build this complete application in literally one page of code. This whole thing actually just works. The only thing I've elided was there's some annoying code for deciding what frame to pull out, what second frame to pull out of the image. And I think what happens here when you have tools that make it easy to compose everything is that now there's not this mental burden of doing serverless versus containers. They feel more familiar and a more similar experience. So when you're using Pulumi to define containers, you stop having to think about things that aren't inherent to the problem. You still need to think about your Docker file, but you don't need to worry about building the container image and getting the container into production. So only the inherent complexity of the problem remains. All of those things that have nothing to do with the problem go away. And when you're using Pulumi to build serverless applications, you can easily reference other cloud resources, and you can even define your functions in line and deploy to any of the major clouds. So you can deploy to AWS, Google, or Azure. And this is the advantage that tooling brings. When you have a tool, it's taking care of some of those problems that the platform wasn't solving for you. If you define infrastructure using code, and you're using Pulumi, it turns it into a declarative plan, and it makes it really easy to combine both serverless and containers with just one tool chain. But even if you're not using Pulumi, I want you to think more about your problems and think about whether or not you're just picking default answers. Are you just picking serverless because you're familiar with it, or containers because your teammates are really, really into Kubernetes? And think more about what makes sense for the problem at hand. So serverless and containers each have their place. Containers are great if you have a durable workload or if you need to customize your execution environment, either in terms of software or hardware. Serverless is great for event-based code that needs to scale on demand. And if you use tools that make it easy to combine both, it no longer feels like either or. You can use both together. If this is your first time hearing about Pulumi, you can learn more at pulumi.io. The project is also open source on GitHub. Thank you.